Today, we're going to be talking about unlocking the cloud operating model, which is sort of marrying the HashiCorp solutions along with Microsoft Azure. My name is Armon Dadgar. I'm one of the co-founders of HashiCorp and CTO. So for those of you who have never heard of HashiCorp, we're really very much focused on the cloud infrastructure automation space. So as a result, we have a wide portfolio of tools. We're probably better known for our tools than we are for the company itself. So you might have heard of tools like Vagrant, Packer, Terraform, Console Vault, etc. All of these are part of our sort of broader portfolio, which really looks at how do we provision infrastructure, how do we secure it, how do we connect all of our different applications together, and how do we run our apps at scale. The company itself was founded about 8 years ago in 2012. Today, we're a little over 1,000 employees and have raised about $350 million in total funding. We count over 1,000 enterprise customers. The tools themselves do over 85 to 90 million downloads a year. And on a monthly basis, we're adding 6,000 new users to Terraform Cloud per month. Right? So you get a sense for the size and scale, both not only on the open source community, as well as on the commercial side of HashiCorp. And so I think one of the areas where we spend a lot of time talking about how our tools can be used in conjunction with Azure is in this broader migration that's taking place from traditional private static data centers into cloud. Right? So when we look at the traditional data center, tends to be very static, tends to be we have dedicated infrastructure for our various applications. And as we're going through this translation to a more modern data center, we're not necessarily abandoning the private data center or the on-premise environment, but we're modernizing that into more of a private cloud. And alongside of that, adopting one or more public cloud vendors such as Azure. Right? So I think the common pattern we end up seeing here is oftentimes our system of records, our core databases that have our user data and our core transactions, those might be staying on premise because we've architected our systems around them for many years. But our new systems of engagement, our new mobile website, our new API, our new consumer-facing applications, those are increasingly living in cloud where we can move much faster, right? But all these things need to work together. And so the way we like to think about it is decomposing the challenge into multiple layers, right? And so like I said before, we think about these 4 key layers. One is provisioning, which is historically an operations-focused area. And I think the challenge there is in a static environment. Largely, we had dedicated servers. They were relatively homogeneous. Maybe they were all VMs running on something like VMware, and they were fairly static. As we move into the sort of cloud world, it's a much more dynamic infrastructure, right? We don't think about buying hardware and depreciating it over years. Instead, that capacity is on demand, so we're scaling up and down continuously. It's much more heterogeneous. We're going to have some mix of VM-based apps, container apps, serverless type applications. So we have a lot of different sizes and shapes that our infrastructure comes in, right? When we go up a layer and talk about the security challenges, historically, this was a focus of our security teams. Increasingly, our operations teams are involved as well. And I think in a static world, we use this sort of high trust perimeter-driven model, right? So we protected the 4 walls of our data center. We brought all of our traffic in through a single point of ingress and egress. And we put a bunch of controls there such that we could assert that the inside of the network was high trust, right? So this is a fundamentally IP-based approach. Versus as we're moving to this more modern cloud-based infrastructure, we start to be much more identity-based, right? We talk about service principals and IAM roles, right? So these are identities with different capabilities associated. Similarly, we don't have a single point of ingress and egress anymore. There's many points where data is flowing in and out of our networks. It's very hard to have a well-defined perimeter, right? So in the modern world, we move away from sort of this perimeter-centric view into this one where we say, I don't necessarily trust my network. It is low trust or zero trust, right? And I want to move away from IP as my unit of control towards identity. When we talk about the networking layer, again, similar shift, right? We had a static infrastructure, so we could put a load balancer pointed to a static set of IPs and a host represented a service. Into now in a modern world where we think about actual true services, right? I might have 20 different services on one node because I'm using containers and technology like Kubernetes. And so the amount of things running on a node is highly variable. It's highly dynamic. So the node doesn't really mean anything. The IP doesn't really mean anything. Instead, we have to think about logical services and how we connect them together, right? And it's a much more dynamic environment. Lastly is our runtime layer. And again, we're moving from static infrastructure where we might have said these 50 machines are a web server, these 10 machines are a database, into doing dynamic scheduling across a fleet of servers, right? So this is where something like, again, like Nomad or Kubernetes, where I have this pool of resources and I'm layering my applications on top of it in a very dynamic way. So our view is there's this philosophical approach that's different in the static world versus the new dynamic world. Now, I think one of the challenges is we had different set of technology in each of these environments, right? In our on-prem environment, we might have been using something like VMware to provide a lot of those primitives, versus in Azure, of course, there's native primitives available, right? So this is things like Azure Resource Manager for provisioning, might be Azure Active Directory for identity, proprietary approaches to networking, and things like Azure Kubernetes Service for our runtime, right? And so you start to see how we get this fragmentation of tooling across these different environments. If we're operating both on-prem and in cloud, we now have so many more tools that we have to deal with. So this is really where the HashiCorp approach comes in. It's really about providing tools that work across these different environments in a consistent way, right? So I can use something like Terraform to manage my provisioning both on-premise against my VMware resources, but in the cloud as well against my Azure resources. And so kind of taking a big step back, more broadly, the way HashiCorp thinks about our role is how do we enable our customers to deliver their workloads in a consistent way, right? With a single tool set, with a similar process, consistently across all their different environments. Because in our view, every company is going to become a multi-cloud company, especially when we include sort of on-premise private cloud as one of these landing zones. And so our relationship with Microsoft, it goes back many, many years. It's a long-standing partnership built on top of a bunch of co-engineering at the heart of what we do together, right? And so we're going to highlight a few of these things as we go, but there's definitely been deep engineering partnership across the HashiCorp portfolio and across the Azure portfolio to make sure all of these solutions work together and that we're delivering a tight and seamless experience for our joint users. I think one of the areas where we started our collaboration earliest was around integration of Terraform with Azure to enable an infrastructure as code approach to provisioning. And so when we look at the Azure provider today, recently went to a new 2.0 version. It contains over 350 different types of resources on Azure that you can manage through Terraform. It's done over 26 million downloads over the last few years, right? In addition to providing just the raw resources that let us specify and configure however we want, there's also 350 different publicly available modules available for Azure on the Terraform registry that have opinionated defaults for how to set up everything from a load balanced group set of VMs to our private networks to firewall rules and much more. In addition to just the provider that works with Azure, we also have a dedicated provider for Azure Stack. So for customers that are deploying Azure Stack on-premise, they can again apply Terraform to manage that in a consistent way. So you can use Terraform across Azure Stack on-prem, Azure Public, as well as other private data center resources they might have. And similarly, there's an Active Directory provider that allows us to bring this sort of infrastructure as code approach to managing users and groups and permissions and apply that to Active Directory as well, right? So lots of engineering work across the Terraform front to really make it seamless, not just with Azure, but the broader set of Microsoft technologies. The next one is this sort of concept around a cloud adoption framework. So I think Microsoft has done a great job defining a framework to make it easier for enterprises that are adopting to think about what's changing in terms of their security approach, what's changing in terms of their management approach. And to make this easier, we've partnered with Microsoft in terms of defining landing zones for Terraform. These landing zones are sort of an opinionated configuration that you can use that helps you sort of skip a lot of the basic grunt work of figuring out how should I set up a network, how should I set up a firewall. It gives you that sort of best practice, 95% sort of works out of the box. And that way you can customize only that last 5% instead of rebuilding the sort of 95%. So this is a great effort that we've partnered with Microsoft on. It's all done in the open source, so you can go see all of these modules. You can fork them and customize them as you need. Today, it's comprised of 24 different submodules. So for everything from firewalls to networks to how you should do diagnostic and support, all of those are available, and you can pick and choose which modules make sense, all tied into a larger cloud adoption framework. The next big area of focus for us is really on the networking side. How do we make it seamless and simple to do networking? And this can be cross different services. So if I'm using Azure Kubernetes service and I'm also using Azure VMs, how can I have traffic go back and forth between my modern container apps in Kubernetes and my more traditional applications running on VMs, right? There's a networking challenge, a discovery challenge between them. Similarly, as I'm going region to region, if I have multiple Azure regions, how does traffic flow between them? If I have multiple Kubernetes clusters, how does traffic flow between them? And then ultimately, how do we even support an on-premise to cloud or a cloud to on-premise pattern, right? Where we need these different sites to be able to network to one another, discover and route, and do it all in a way that's secure. So Consul is really designed to help secure all of that and support those different types of workflows, whether it's cross-region, cross-premise, or multi-cloud. Consul fits into all of that. So we partnered very closely with Microsoft over the last 18 months to build a first-class service on Azure. It's called the HashiCorp Consul Service, and it's available directly through the Azure Marketplace. So you can see a screenshot of this here, where the UI of Consul is directly being rendered inside of the Azure portal. So it's a very deep integration. It leverages the identity and billing in a totally integrated way to Azure, so it feels like a native service of Azure. And this is now generally available. Another big area of focus is with Vault. So with Vault, we're really looking at the security challenge of how do we manage credentials, certificates, database usernames and passwords, cloud API keys. We need to securely store these at rest and distribute them to our applications in a secure way, such that we have tight authentication of who's logging into Vault, tight authorization, so you only need access to the minimum number of credentials that you need, and tight auditing, right? So any action that takes place, we should have visibility on it. So within the Azure ecosystem, there's a number of major integrations. One is tight integration with identity, right? So when we want to authenticate different workloads, that's done by deep integration with Azure AD, right? So here's an example of what that workflow looks like with various workloads that are running on top of Azure, whether it's a VM or a container or a serverless type function. We can do that integration with Azure AD and use that to verify the client's identity. That provides the authentication such that they can be authorized to request whatever credentials they need, right? We also work closely with Microsoft on deep integration with Vault and making sure that there's tight ways of using Vault within Kubernetes so that you can get credentials in those types of environments as well. Next is our work around HashiCorp Packer. So when we're building machine images and these kind of golden images, what we need to do is start with sort of the source code, the configuration management, the different controls, and ultimately use that to bake a suitable machine image, right? This machine image could be a Linux image, could be a Windows image, right? It could be designed for different cloud regions we have or development versus production environments. And so the goal of Packer is to allow us to automate this sort of image creation process, right? So Packer has, obviously strong support for the different Azure resources. But over the last year, Microsoft actually introduced a new service called the Azure Image Builder that's actually built on top of Packer. So underneath, the service uses Packer and leverages it to automatically build these machine images and keep them up to date for you. Just another example of a great partnership with Microsoft of really not only integrating, but also deeply embedding and supporting Microsoft Azure. Lastly, we just introduced a new tool very recently called HashiCorp Waypoint, which really looks at how do we bring a consistent developer workflow across any sort of a runtime service, right? So although there might be a lot of tooling and focus for a specific platform, most enterprises use many different platforms. They have some set of applications that are VM-based. They might have some set that are running on Kubernetes. They have a different set where they're exploring serverless offerings like Azure ACI. And so I think the challenge ends up being, how do we present a consistent workflow for our developers so that they don't have to learn 3, 4, 5, 10 different ways of building their application, deploying it, managing releases. And so this is really where Waypoint fits in. It provides a single consistent developer experience, whether we're building the app, that might be a VM-based image, might be a container-based image, right? So we'll build the app in a consistent way. We'll deploy in a consistent way. So this supports things like AKS, as well as Azure Container Instances, ACI. So the deployment onto these two totally different platforms can be done in a consistent way. And then when we do a release and cut traffic over, again, that's designed to be pluggable so that it's consistent across the different ways we're managing traffic, whether that's using a tool like Consul or an Azure native traffic management solution. So really looking at simplifying the developer experience, making it consistent, but highly pluggable so that we can support the breadth of the different Azure services.